let's talk about negation of if P then Q statement. Okay. Now negation of if P then Q statement is given by that scenario where P happens and Q doesn't happen. Okay. So if you would recall, if P then Q, if you say it is, if it's a true statement, it will only be true when P happens and Q happens. Or if P doesn't happen and Q doesn't happen, or if P doesn't happen and Q still happens. So the only scenario where your statement if P then Q is said to be negated when P takes place and Q doesn't take place, right? So this is the negation of if P then Q statement. So they are logically equivalent. This is symbol of being logically equivalent. Can we verify this through a truth table? So let's make a truth table of P, Q, if P then Q, negation of if P then Q, negation of Q and P and not Q. Okay. So let's say this is true, true. We all know it's true. Remember the example of the husband and wife. Gets a promotion, takes his wife for the foreign trip. So good husband means true. Negation of true being false. Negation of true here, Q's negation is true. Q negation is again false. Okay. So true and false is going to be false. Okay. So keep an eye on the result that you obtain over here and the result that you obtain over here. Ultimately, we need to show that the logical outputs in this column and this column should be identical. Let's take true, false. Husband gets a promotion, doesn't take his wife for the foreign trip. Not a good husband, so false. Negation of this is of course true. Negation of false is true. Now true and true becomes a true. Again, we got the same logical output in this case as well. Let's take false, true. This will be true because he doesn't get a promotion, still takes his wife for the foreign trip. It's a good husband, so true. Negation of this will be false. Negation of Q, which is true, will be false. False and false makes a false. Again, you can see we get the same logical output in this case as well. Finally, taking false, false. This is true. So negation of this will be false. Negation of Q will be true. P and true, false and true will make it a false again. So again we see we get the same output here as well. So we get exactly the same set of outputs as we got for negation of P implies Q and P and not Q. Hence these two statements are logically equivalent. So just remember this. Negation of if P then Q is P and not Q. Next we'll talk about biconditional statements or biconditional implications. Okay. Better known as if and only if statements. Okay. You must have heard of this phrase earlier as well. We used to write it as a shorthand of IFF, if and only if. So in this case, what happens? Two simple statements are connected by the phrase if and only if. Right? So let's say if P and Q are connected by if and only if. For example, if and only if P, then Q. Okay, then this becomes a biconditional statement. Symbolically, we write it as this. So here we have used a bidirectional arrow to show the logical flow of reasoning from both the sides. That means if P happens, then it implies Q, and if Q happens, then it implies P. Okay. To give you an example, let's say if and only if you give me a burger, I will eat. Okay. Now here, if you see, you giving me a burger is statement P, and if I'm eating, then it's a statement Q. Now this implies that if you give me a burger, then it automatically implies I will eat. So if somebody comes and says, hey, I give a burger, then that person will automatically understand that I would have eaten that. Similarly, if somebody says, hey, Akhil ate, then it means I was given a burger. Right? So the flow of information is in both the directions, which was not the case in case of conditional statements if and then. So here, if P happens, then Q automatically happens, and if Q happens, then P is also assumed to be happening. So P implies Q and Q implies P. So in case of a biconditional statement, you can consider this to be a conjunction of two if-then statements. So this and this is equivalent to saying if and only if P, then Q. Right? So if P then Q and if Q then P is equivalent to saying if and only if P then Q. In other words, they are logically equivalent statements. Alright. Now let us look into the truth table for if and only if. So let's talk about truth table for if and only if statement. Okay. Now, as we already saw in the previous set, if and only if statement is said to be true if P happens and Q happens, and if Q happens, then P happens. Alright, so let's take P as true, Q as true, then we know this is going to be true, and reverse is also going to be true, and true and true. Note that you have to do this conjunction of these two statements. That means you need to connect them by and connective. So this is also going to be true. Okay. Let's say this is true, this is false, then we know this is going to be false, and the reverse direction, this is going to be true, and false and true is going to make a false. Okay. Let's say this is false, this is true, then this is going to be true, and this is going to be false, and true and false are going to be false again. And if this is false, Q is also false, then if P then Q is going to be true, if Q and P is again going to be true, and we know true and true conjunction is also true. So the only situation or only times when your if and only if P then Q is true, when both the statements here are true. So when both of them are true, your statement if and only if P then Q is true. Or if both of them are false, if both of them are false, then only if and only if P then Q is going to be true, right? So this is the truth table for if and only if P then Q biconditional statement. Now let's talk about the negation of if and only if P then Q statement. Okay. Mind you guys, here we are trying to negate if P then Q and if Q then P. Correct? And we have already learned that if we are trying to negate two statements connected by the AND connective, it becomes not X or not Y. Right? So in a similar way, it will become not if P then Q or not if Q then P. Okay? And in our previous segment, we have seen the negation of if P then Q is P and not Q. Okay? Let's copy this OR here. And negation of if Q then P would be Q and not P. Okay? So, these two statements are logically equivalent, remember? Not of if and only if P then Q is equivalent to P and not Q or Q and not P. Try to prove it by using your truth table. Try to prove by truth table. Okay? The next important thing that we are going to talk about is certain aspects related to if and only if. Okay? Sorry, certain aspects related to if P then Q. Now, there's something called converse of if and only, converse of if P then Q. The converse of if P then Q is if Q then P. Okay? Similarly, there is inverse of the statement which says if not P, then not Q. And then there is a contrapositive of the statement which says if not Q, then not P. Okay? To give you an example, let's say if a number is divisible by 9, then it is divisible by 3. Okay, let's say this is a statement which is if P then Q. Then the converse of this statement will sound like if the number is divisible by 3, then it will be divisible by 9. Now, as I say this, try to ask yourself, is the converse true if your P implies Q is true? Right? So think about this. If I say if a number is divisible by 9, then it is divisible by 3. If this is true, can I say the converse, that is, if a number is divisible by 3, then it is divisible by 9 is also true? No, not necessarily. Right? For example, a number 6 is divisible by 3, but it is not divisible by 9. So if a statement, if P then Q is true, then its converse need not be true. Right? Similarly, if you look at the inverse of this statement, then it will be read as if a number is not divisible by 9, then it will not be divisible by 3. Now, in this case, even this statement may not be true. For example, a number 6 which is not divisible by 9 can be divisible by 3. Right? And finally, contrapositive will sound like this. If a number is not divisible by 3, then it will be not divisible by 9. Now just pause and ponder that if P then Q is true, will its contrapositive will always true? If yes, then try to verify that the truth table for this will be same as the truth table for this.